Okay, it occurs to me that I've done a lot of videos over the years on home lab and home server and storage server, and looking at it from a practical point of view. I recently did a video on the Minis Forum MS-01. It's their like small form factor workstation machine. It's in here. We'll get to that. The question has come up a lot, which is how do I attach a lot of hard drives to my machine? I'm going to show you how you can attach 24 mechanical hard drives to your MS-01 and turn that into a pretty powerful media server machine, because it's got all the horsepower, it's got 10 gig Ethernet. All we got to do is add one PCIe card. But more importantly than just showing you how to do this, I want you to learn to think about it the way that I do. Think about it in terms of independent electrical connections and will it bottleneck more so than will it physically fit. We looked at GPUs. GPUs in the MS-01, single to half height slot, single slot. It's just, there's not physically room for a lot of different kinds of GPUs in there. And yet, if you're willing to run a cable or get creative, you can cram a bunch of stuff in there. Similar to this is an AM5 server-ish platform. It's got out-of-band management, built-in 10 gigabit Ethernet, an X4, and an X16 slot. This is a lot of possibility, but it's only got 4 SATA ports. That means we can't possibly run, 24 to 30 SATA drives off of this, right? Well, it turns out you actually can. Let's take a closer look. The magic that makes all of this possible is a SAS controller like this. This is an LSI 9308E. E is external, I is internal. You want the E. And this has a full height bracket on it, but most of the time they'll come with a full height and a half height bracket. Half height is what you want for the MS-01. So when this is laid out in the system, it basically takes up the whole system. And this gives you 2 connections that can go to an external disk shelf. Now before we talk about the disk shelf, we need to talk about the connections here. I'm using SATA and SAS interchangeably, but they're not truly interchangeable. One thing that you really should keep in mind is that SAS is designed to do this. SATA is not designed to do this. It may happen to work, but you're going to invite headache. As I do this video, I'm going to tell you things that this is more likely to cause a headache for you, this is less likely to cause a headache for you, and it's a theme that's going to recur. What I want to do is help you understand things from my point of view. If you're building a home storage server and you're talking about 5 or 10 or 12 hard drives, then okay, maybe you don't need an external disk shelf. I think that Home Lab, the HL15 from 45 drives, is a good choice for 15 drives or less. There are some trade-offs with that, but it is also technically designed for SAS, the backplane SAS, the electrical signaling SAS, etc., etc., etc. SAS stands for Serial Attached SCSI. It's a commercial implementation. It provides a lot of features. Some of them are optional. One of the features it provides is called a redundant path, meaning that the drive has 2 sets of connectors and it can talk to 2 different controllers, or it can have 2 paths on the same controller, depending on whichever way you want to do. SATA drives don't have that. And so depending on what enclosure you're using or what disk shelf you're using, you may or may not have a redundant path with SATA hard drives. But SATA wasn't designed to push cables this long. SATA was designed to push cables about this long, and it's not really well tested. SATA also tops out at about 600 megabytes per second. It's, SATA 3, 6 gigabit per second, 600 megabytes per second, fudging the numbers there a little bit. Whereas SAS, 1.2 gigabit, 2.4 gigabit, that is mainstream. Basically, SATA hasn't changed much in a decade, but people, don't want to necessarily go to NVMe, which is your next step up. It's SATA, SAS, NVMe. And SAS can reach far into the past in terms of server support, and NVMe is the new hotness. NVMe is PCIe signaling. A lot of corporations that make this kind of stuff aren't ready to deal with PCI Express signaling. It's like PCI Express bus is the thing. And companies like AMD don't really help because their CPUs on the same physical sets of wires can speak SATA and they can speak PCIe, but they can't speak SAS. And so the same physical wire inside the CPU is wired up to 2 different sets of electronics, which is pretty wild, but it confuses people sometimes and they don't understand it. So I want you to understand that you can use SATA drives on a SAS interface, but SATA works better if the protocol actually becomes SAS. So let's take a look at a disk shelf. There are several versions of this disk shelf, but this disk shelf is pushing 10 years old, 12 years old. in some cases. I've done videos on this. I've given these away to other YouTubers. Linus has done videos on these. Linus has called me for tech support on these. These are amazing, like LSI, NetApp, these are incredible enclosures. As time goes on, they're less incredible because of the passage of time. It makes them less awesome because they're slower and weirder. This particular one, this is an I/O module at the back. And this particular one is an IOM3. IOM3 is SAS3. This is very slow. This connector is called QSFP Plus, and it'll work without all the NetApp stuff. So you can just use this as a disk shelf. What that means is that you plug in hard drives in the front, and it's just serial attached SCSI, SAS. It's completely standard, except for the connector. You gotta get a special cable to go from this to the square connector on the card. But electrically, this is standard, which means that that card will be able to see all 24 drives in this chassis. You've technically only got 8 lanes, 2 4-lane connectors, but they're SAS lanes that go to this enclosure. But a mechanical hard drive, you know, it's going to be a little bit of a challenge for a mechanical hard drive to use all of the available bandwidth. Certainly for SAS6, and LSI does make IOM6 modules, and it would behoove you to look out for modules that are IOM6. This type of enclosure doesn't make any sense to use with SSDs, SAS or SATA. You would be better off with direct connections one-to-one in every case. And in that case, the 45 drives enclosure can really make a lot of sense because it is a one-to-one, like one connector, one lane goes to one drive. There's also the power supply situation with a shelf like this. This is designed for high-end enterprise hard drives, which could be up to 15,000 RPM. And in that configuration, this would have to have 4 500-watt power supplies. As this one is configured, it only has 2 500-watt power supplies. The idle power is still pretty high, though. This was not designed for power saving or anything like that. This is going to be fairly loud, although not ear-splitting. And this is going to use, 250 watts just idling. Our little Minis Forum PC is like 12 watts idling. But if you think about it this way, this is your 10 gigabit Ethernet adapter, dual port Intel X710, to your disk shelf adapter. You can put all kinds of storage in here. You got room for 24 hard drives. I've tested this shelf with 22 terabyte mechanical hard drives, and it works fine. This is also the enclosure that I've used for like the dual actuator hard drives, which are really, really fast mechanical hard drives, but this disk shelf is a little on the slow side if you're gonna use disks that fast. Yeah, the dual actuator drives can actually be substantially faster. You can also get native SAS dual actuator hard drives, although those are usually not as cheap as their SATA counterparts, but the native SAS hard drives, much better in this enclosure. But it is kind of funny that this is the brains, the multi-core brains with 32 or 64 or 96 gigabytes of memory on this little tiny thing, and then plugging into the giant disk shelf that uses many, many times more power. But that's sort of where we are. This also would work for an old machine that you have laying around. Our old forum posts, builds from other people. You could also check out Serve the Home's Tiny Mini Micro project, because small form factor business class machines usually are pretty easy to get a hold of. And sometimes they have PCIe slots. When they do have PCIe slots, you can acquire one of those really inexpensively. It's probably going to be older hardware, but then you can use a controller like this and a disk shelf like that, and it's the same situation. You've got 24 mechanical drives connected to a small form factor machine, and this can be the basis of your ultimate media storage machine, because you could pack in a 1/4 petabyte on this if you spend the money on the drives, and the bulk of your spend would be on drives. The other nice thing about this is that if you were to try to cram 10 or 12 mechanical hard drives into a single chassis, generally that single chassis is not as hardened against anomalies, things like lightning strikes or static discharge, cooling, etc., etc. I guarantee you that this sled has orders of magnitude better cooling than any ATX chassis out there, except possibly the 45 drives chassis, which is designed with 6 fans and front to back cooling. It's designed with a similar heat load in mind. But putting this much computational horsepower plus storage in an ATX machine, sometimes your power supply might be a little bit suspect, sometimes the wiring might be a little bit suspect, sometimes you might be tempted to use on motherboard SATA. Almost all of the forum posts and headaches that I've read over the years where people were using ZFS and something catastrophic happened has almost entirely been hardware related or related to I've crammed 500 hard drives on my motherboard that wasn't really designed to handle 500 hard drives. Or I've done some Herculean thing in order to be able to hook up more than 15 or 16 mechanical hard drives in a single chassis. So if you do that, make sure that you've got a plan B route, so if something goes wrong, you have a way to get all your drives hooked up. When you're using SAS with a disk shelf like this, there's 2 controllers, and there's 2 paths to each drive. So you actually do get a little bit of a warning if a power supply dies or a controller dies or it has some sort of normal typical failure. Usually that's non-fatal because it has a redundant path and it has redundancy built in. So for this disk shelf, I pulled out one of the disks, and yeah, as large as it is, that's all there is just a disk in the front. And because this is SAS, this is all you need. Pretty much, it works great. If you're using SATA with one of these shelves, you need what's called an interposer. The drive will actually sit a little farther away, and there'll be a little circuit board at the back here, and that'll adapt dual path SAS to single path SATA. And that was NetApp's solution for providing a dual path to each individual disk, and it works having the interposer. The other thing that this gives you is the stability of SAS electrical signaling. Without the interposer, the drive is talking to the controller with SATA signaling levels as opposed to SAS signaling levels. SATA signaling levels may increase your headache factor. There's a greater chance of something going wrong or disks being misdetected or having a little bit of noise in here that introduces a little bit of error. If you're using a RAID system like Unraid, you may have undetected errors that creep in as a result of cabling or signal issues, depending on the file system that you use and how you set up error detection and error correction. So just something to keep in mind. LSI also has another version of this disk shelf where there's actually 2 disks that are back to back. You got to get creative with that in terms of when you pull a shelf, are you going to lose the entire pool because there's multiple failures because you pulled a sled that contains 2 disks. But depending on how you set up your disks, you can set up the pool to tolerate that. Or you only pull disks when it's actually off and unplugged to replace a disk that has failed. That would also solve that problem. It's wild to me that an enclosure, a shelf like this, can support 18, 20, 22 terabyte mechanical hard drives. But at the same time, you don't want this to be the bottleneck. We've gone from an era where the fastest 15,000 RPM hard drives could do maybe 200 megabytes per second to, pedestrian 18 terabyte single actuator hard drives can do 170 megabytes per second, and the dual actuator drives, well, those can do 500 megabytes per second. Mechanical hard drive clearing 500 megabytes per second. It's possible at this day and age, which is amazing. So what about the 45 Drives home lab system? That's sort of everything all in one box. And that is sort of the maximum that I would run in a home lab non-truly enterprise scenario. So this is literally my home lab 15 setup that I actually have for using at home. The only thing I've done here that is extreme maximum overkill is I've put a Genoa CPU in it. It's AMD's latest and greatest. And it's because I don't intend to do anything with this machine for a decade. Like, it's just gonna go run and be fine. I've actually pulled the GPU because I'm doing some experiments with my home lab, building a large language model I can talk to and just control things in my house. That's a video for another day. What we're talking about today is this a reasonable alternative? And when you buy the chassis, you get a chassis you can put any kind of a machine in. It can be used, it can be old. You don't have to spend thousands of dollars on Genoa gear and DDR5 memory. You can put whatever you want in here. They do give you the backplane and an interface so that you can plug it into a SAS controller. I haven't done that with my setup, so if you want to see more about this setup, I did a video on it, you can check that out. But what I'm trying to tell you with this setup is that you don't really save a ton of money going the used route by the time you get all the stuff. This will only hold 15 drives as opposed to 24, but you can also put the compute resources and everything else in here. This uses a standard Corsair RM750E power supply, which 45 Drives has had good experience with. Powering this sort of a use case, your mechanical hard drives do generally tend to use mostly 12 volt power, but a little bit of 5 volt power. Sometimes when you're running a lot of mechanical hard drives, it can be a little bit more power than some ATX power supplies really have in mind that you're going to use on the 5 volt rail, because most motherboards, CPUs, that's all 12 volt. All of the voltages other than 12 volts are basically just for other random stuff. There's not a lot of power delivery facilities for 5 volts if you want to think about it that way. This motherboard's also super unusual. Like, I bought this, I actually paid for the motherboard and everything in here. I sort of borrowed the processor from work, but I'm hoping that we'll see some Genoa CPUs on the secondary market at some point. But the other unique thing about this motherboard is it has dual mini cool edge port groups. So I can run 2 NVMe, U.2 NVMe off of one single connector. This motherboard's got 4 of them. So 2 connectors I'm using for my SATA hard drives, and 2 connections I'm using for NVMe. And I also mention this because this is a little bit violating the rules that I already gave you. It's like SAS usually is a better choice than SATA. But I'm using ridiculously short cables. Like, they're not going very far from the motherboard to the drives. And so that helps me claw back a little bit of my reliability. The way the 45 Drives actually ships this is with a legit SAS controller though. So like, if you want to do it right, you can connect this to a SAS controller, and that totally works. It's me going off script to use this with the SATA connections provided on the Genoa motherboard, and I'm taking a little bit of a risk, but because I'm using ZFS and I'm monitoring, etc., this setup has been very, very stable for me, even though I've been hitting it really hard for the last 4 months, and I think that was an important piece of data to share. I'm Whittle, this is Level 1. This has been a hopefully not too rambly video about what you need to think about if you're thinking about building a home server or small business server that has a lot of mechanical hard drives attached to it. Basically, unless you're doing the HL15 from 45 drives, I would say that like 8 or 9 mechanical hard drives in a Tower ATX case, you know, Fractal, Corsair, Antec, all have options that have a lot of 3.5-inch bays. You don't want to cram a ton of hard drives in there. Something like this disk shelf would be a little bit better in terms of reliability and a little easier in terms of disaster recovery. But you can think creatively. Like, just because physically we can't fit 24 drives in our Minis Forum MS-01 doesn't mean we're going to miss out on the 24 drive party and be able to run, you know, a petabyte of storage or more off of this and have our native dual 10 gig SFP Plus connections on the back of this, which is really, like, the fact that I can do that in a package this small and still have Thunderbolt, which you can use for another 20-ish gigabit connection, and all of the other horsepower here, it's really pretty fantastic. And that Intel CPU with QuickSync and its iGPU and those features in terms of a media server, that's pretty awesome. It really is. So yeah, there's your formula. It's like an MS-01 plus a disk shelf, and you could get a 12 drive disk shelf or a 14 drive disk shelf, or one that has a different configuration. It's just a matter of finding the right SAS adapters and making sure that your disk shelf basically is just a glorified standard SAS disk shelf. That's basically it. I'm Whittle, this is Level 1. I'm signing out. You can find me in the Level 1 forums if you have any questions. But if you embark on this journey, post pictures. And a lot of people already have over the years, because I've been doing this for years, and there's a lot of really interesting builds in the forum and stuff that people put together to show off their systems. Everything from HL15 builds to, I made this out of e-waste. And everything is basically e-waste, except for our new MS-01 head machine or our AM5 motherboard or whatever route you decide to go. All right, I'm signing out, and I'll see you there.